All right. Hello, everybody. Hope you're doing well. This is the video for Thursday, the 16th of April. It goes along with Algebra I Worksheet 14. So we just have some SAT prep questions. These come directly from your textbook. The first one has to deal with calculating time and the duration of a trip. Okay. So if we said that we were going to travel, and I'm in a Sunday school classroom, so you're going to see some Sunday school material on the wall here. But if we said we were going to travel 60 miles per hour, this is miles, this is per hour, okay? So miles an hour. That means that in the space of 1 hour, we will have gone 60 miles, okay? So think of that as kind of the starting point. If you divide your hour into minutes, how many minutes are there in an hour? Well, there are 60 minutes in an hour. And so if you're driving 60 miles per hour, you're driving 1 mile per minute, right? Now, if you're going faster, let's say we're going 100 miles per hour. Okay, this is a faster rate of speed, and you want to know, well, how long will it take for me to travel for 1,000 miles? If I have 1,000 miles and I'm driving 100 miles per hour, I'm going to divide my distance is going to equal my rate times my time, okay? My distance is going to equal my rate times my time. And so if I want to know time, okay, like how many hours is it going to be, then I'm going to leave my t here because that's what I don't know, and I'm going to say my distance is 1,000 miles equals my rate, which is 100 miles per hour, which can be written like that, times t, okay? How do I find t? How do I solve for t? Well, I'm going to divide both sides by 100 miles per hour, okay? So this is going to cross out, and I'm running out of time here, or running out of space here. But notice that over here, 1,000 divided by 100 is going to equal, let's write it over here, t equals 10, and the miles are going to cross each other out, right? So miles divided by miles, that's going to get rid of that, and all that's left is hours, okay? So distance equals rate times time, and I feel like you can do that one. The second problem on today's worksheet has to do with area of a two-dimensional object. So if you have a rectangle, we're going to call one side length and the other width, and the area is going to equal length times the width, okay? But what if part of your rectangle is missing? What if, for example, you've got, well, I don't know, a hole in it, okay? Let's say that we know our length is, I'm just going to make something up here, 20 feet, and we know that our width is, let's say, 10 feet, okay? And then we know that this is 10 feet and this is 5 feet. Well, what do I have to do? I have to calculate the area of the missing area, okay? This missing space, so I've got a 10 by 5 space that's cut out. Well, that's 50 square feet. And I'm going to subtract that from the total, and you can see that this whole thing, if area is length times width, the total area is 10 times 20, which would be 200 feet squared, minus this area that's not included. So you might have to use your imagination to figure out how big that space is that's not included. And I know that if you put your problem solving skills to work, you can figure that out. All right. The third question has to do with graphing. And so I'll remind you, okay, I'm going to switch markers here. If we're graphing a line and it has no slope, in other words, it's exactly vertical or horizontal, okay, vertical would be up and down, horizontal would be flat, then it's going to be very, very easy, okay? The formula for a vertical or horizontal line is very easy. If it happens to be horizontal, and let's say that we're right here at, this is our x and this is our y, okay, so we count down -1, -2, -3. So anywhere that y equals -3, that's my line, okay? What's my line? Y equals -3. What's x? Any x in the world, okay? All the x's. No x's, all the x's, x equals 0, x equals 1,000,000. Doesn't matter what x equals, my line is y equals -3. Anywhere that there's a -3 for y, my line is there. That works the other way for a vertical line, okay? +1, +2, x equals 2. So this would be x equals 2 right here. So let's call this our second line, okay? We'll call this our second line, put this right here. Anywhere that you have a vertical line, it's x equals +2. What does y equal? Doesn't matter what y equals. For all the y's in the world, x that equals a +2, this is my line. Now, where it gets a little more complex is where we have a line that's got a slope. For a line with a slope, we want y equals mx plus b. And m is our slope, and b is our y-intercept. In other words, the number hanging out here on the end is wherever our line crosses the y-axis. That's our y-intercept, okay? So let's say that I've got a line that's doing, I'm going to do something pretty simple here, okay? So this guy, I don't know if you can see it, he crosses the y-axis at -1, and he crosses the x-axis at a +2, and I'll tell you why that's important. I'm going to write my formula now. I'm going to write y equals, I'm going to leave a space for my slope. I haven't calculated my slope yet. It's something x, okay? And then what's my y-intercept? -1 minus 1, okay? So my y-intercept, or my b, is -1 because this line crosses my y-axis at -1. So now I have to calculate my slope, and slope is rise over run. So I have to treat it like a fraction. How far does it rise? Does it rise positively or negatively? That's going to be on the top. And then run is go forward or go backward, this way or that way, running along that x-axis. That's my run. Now, just like any other fraction, I want to state it in its most simplified form, right? Okay. If the line is sloping up, think of it as an airplane taking off, reading it from left to right like you would a book. That's a positive slope. If it looks like the airplane is coming in for a landing as you read it from left to right like a book, that's a negative slope, okay? So here we go. I need to find my rise and my run. I need to find two places that the line crosses a point that I know exactly what the value of that point is. Well, I know what this point is. It's x equals 0, y equals -1. Okay? X equals 0, y equals -1. And I know at this point is x equals 2, y equals 0. Okay? So how far did I rise? I rose from, and rise is going to be my y-axis, I rose from -1 to 0. From -1 to 0, that is a positive rise, so that's a 1 that goes right here. That's my rise. Now my run, I went from from x equals 0 to x equals +2. That's a positive run. So the algebraic expression of this line is y equals 1/2 x minus 1. Let's do one more where the slope is negative. Let's just choose this guy right here, okay? And let's say that Okay, let's say that he intercepts the y-axis at positive 3, so x equals 0, y equals positive 3, and he crosses the x-axis. That's another point we can identify at x equals 3, y equals 0. Okay, so let's go back to our problem here. We're going to start off with a y equals space x plus or minus something. Well, what's my y-intercept? My y-intercept is a positive 3, so I'm going to write plus 3 here on the end. Now I'm going to calculate my slope. My slope starts off at y equals positive 3, and it rises to y equals 0. In other words, its rise is actually going down. It's a negative number, okay? So I know I'm going to have a negative slope, and I'm going to put a 3 on the top because it's going down, right? The rise was from positive 3 to 0. Do you see how it actually went down that much? Okay, my run is from 0 to positive 3. Well, that's a positive 3. I'm going to put it out here. Okay. So what that means is one of my numbers, either my rise or my run, was negative, which means that my fraction is going to be negative. But look here. A negative 3 over 3. 3 over 3 is the same thing as 1, right? So I'm actually going to rewrite this not as 3/3. I'm going to write this as a negative 1x, or because 1 before x doesn't make any sense, I'm just going to call this one negative x plus 3. Okay? Negative x plus 3. And that's my algebraic expression for this line right here. All right. Love you. Hope you're doing well. We'll talk soon.